Semester 1, we have our student today, Hector.
Hi.
Hello. Alright, so today we're going to be going over Algebra 1, one variable linear equations, solve linear equations in one variable, including those for which the application of the distributive property is necessary and for which variable are included on both sides. So yeah. So to start off, we're going over the basics. We're going to put the equation into variable form in which we're going to solve for that one variable. So the equation we're going to start off with today, just to kind of introduce or get a hands on how to solve for the variable. So we have 4 equal z plus 5. So what we're trying to do again is solve for this one variable being z. So solving for the variable, you have two numbers. What you have to do is get the variable on itself on one side. You kind of follow with me?
Yes.
Yeah, all right. So to do this, again, if we have a variable and the number, what we'll do is we'll move the number to the other side or do the opposite of what the sign of this number on the same side of the variable is asking for. So if we have 4 equals z plus 5, to get the variable by itself is moving the 5 to the other side. And moving the 5 to the other side being, if it's adding, you're going to subtract it to move the other side. So that'll, eraser. So we're going to subtract 5 from both sides. And then when you subtract the 5 from the plus 5, you have a plus 5 and a minus 5. And if you all remember, those just cancel out with each other. And then so here, our new variable we have is 4 minus 5. So the 5 being the bigger sign, you're going to have negative 1 equals your variable z. All right. Any questions so far?
Yes, so do the variables change all the time, or would it be just for
Change how?
day? So would you always subtract, or would you always add?
Add the variable or the number?
Number.
Oh, you're gonna do the opposite of the number, or that's on the same side of the variable. So how you have the z plus 5 to get the z by itself instead of plus 5, that's where you minus 5 and move that to the other side.
Okay.
Okay. For another example, we're gonna do another one. Let's see. We have negative 12 equals 4 plus c. So again, same thing as this one. You have negative 12 plus equals 4 plus c. And again, we're trying to solve for c, getting the c by itself. So if you recall, what we'll do here to get the c by itself is moving this 4 to the other side. To answer your question, so how you saying this? So here we have a positive 4, and to get the to move it over, that's where we make it a negative 4 or a minus 4, excuse me, and then we subtract the 4 from both sides because this cancels out and get the c by itself. So we have a negative 12 minus 4, and again, so that'll be negative 16. And then again, since we have the c by itself, it just comes down, and we have negative 16 equals c. Question so far?
So the letters, they remain constant, that you don't change those?
Yes, correct. The only time you would change it is if this just happened to be like a negative c, or if a number was in front of that variable. If it was like a negative 3c or something like that. And thank you for asking, because that's actually going to be our next step on as far as number being in front of the variable. So our next example we do have is 3x minus 4 equals 5. So now, this time we do have a number in front of the variable. So let's not freak out, because again, it gets easier as we're going to explain. So first we're going to start off with the same step as last time. We want to get this by itself, the 3x. So to get the 3x by itself, what do we have to do to the 4?
You add it, right?
Correct. All right. So we're going to add the 4 to both sides. And then so we just go ahead and bring down the 3x. and then we're going to have the 5 plus 4 equals 9. Now, this is where we do a next step. So far we have 3x minus 9. We want to get this 3x to just be 1x. So what we would have to do is, we would have to divide both sides by the 3. And then what this does, that 3 divided by 3, that cancels out. So that just brings down the x. And then you can have the equal, 9 divided by 3 equals 3. You follow along with me?
Yes.
Yes? Alright. Let's do one more example, just to kind of brush up. Alright, so this example, we have 4x plus 16 equals 4. We'll go ahead and do that. So we have 4x plus 16 equals 4. So what would be our first step to get the 4x by itself?
No, it would be to subtract the 16.
Subtract the 16, correct. So we're going to go ahead and subtract the 16 from both sides to get this by itself. Alright, now we'll go ahead and just bring down the 4x. Then equals, alright, now we have 4 minus 16, which is negative 12. Alright, and then so here we have 4x. So to make that 4x a 1x, what we have to do in this situation?
You would have to divide
Divide
the 4x, or the 4.
the 4, okay, and
From both sides.
yeah, correct. The 4 from both sides. Alright, and go ahead and cancel that out. And then we have x equals negative 12 divided by 4, that being negative 3. That's a negative divided by a positive, so that's where that negative 3 comes in. Alright, so we're going to go ahead and do one more. So this time, we're going to take it up just a notch. This one, if you remember Hector, requires our FOIL method. We have 3 parentheses, x minus 1, close parentheses, equals 12. Do you remember your FOIL method? If you don't, it's fine.
You multiply the 3 times the x and the negative 1.
Yeah, correct. Alright, there you go. So you do remember. Alright, so yeah, so your first step, again, break it down to parentheses. As remember the method PEMDAS. Parentheses, exponent. Yeah, okay, yeah, that. Alright, so like you said, so we're going to go ahead and multiply the 3x. 3 and the x, we get 3x, and then 3 times the negative 1, making that negative 3. And then we have equals 12, and go ahead and bring that down. So now we just broke that down into our main equation, how it was on those other examples. 3x minus 3 equals 12. All right, so what would we do from here to get the 3x by itself?
You would add the 3, right?
Add the 3 to both sides, correct. So add 3 to both sides. And then we'll go ahead and just bring down the 3x equals, and then 12 plus 3 equals 15. And then what we do for here to solve for x by itself?
Divide the 3 from the x and the 15.
Correct. Alright, we'll go ahead and divide the 3 from both sides. And then so we got 3x divided by 3 equals x, and then 15 divided by 3 equals 5. So yeah, so that's what we've done today, solving for one variable linear equations. Okay, so as we did just in the previous example, we just solved the linear equation in one variable. Now what we're going to do now is just prove that that variable was correct that we solved for in that equation. So in the example we did earlier, we did 3x minus 4 equals 5. And then what we did was move forward to both sides. And so we get 3x equals 9. And then we'll just divide both sides by 3. And we get x equals 3. So now we have x equals 3. What we're going to do is now to prove for x, we're going to plug x, the variable for x, into the equation. So again, the equation we had was 3x minus 4 equals 5. You can see that. And then so we're just going to put x in, or 3 for the x. See that there. So now we got 3 times 3 minus 4 equals 5. Right? And so we're going to do 3 times 3 is 9 minus 4 equals 5. And then so we get 9 minus 4 equals 5. And then equals 5. So 5 equals 5. So that's how we know that the variable for x equals 3 is correct. To prove it wrong, let's just say if we put in a different number for x. Let's just say if we put in 5, for example. So if we was to prove, so this is correct. So if we were to put 3 times 5 minus 4 equals 5. Again, just to show that it's wrong. And so we get 3 minus 5 equals 15, minus 4 equals 5, 15 minus 4 equals 11, 11 equals 5. Alright, and that is not correct. So that's how we know the equation that we did earlier, the x equals 3, and then when we plugged in, that gave us 5 equals 5. And then let's do our other example. Let's prove for the second one. How we did on our example earlier. We did 3 parentheses x minus 1 equals 12. Right, and then we solve for 3x minus 3 equals 12. Move this 3 over to the other side. And so we got 3x equals 15. Divide both sides by 3. And so here we got x equals 5. Now, we're just going to prove that that's correct by putting in that 5 for the x. So now, so we got 3, 5 minus 1, because that was x minus 1, just put that 5 in, equals 12. And so here we're going to go ahead and do our PEMDAS, our exponents. So we got 3 times 5, we got 15, we got 3 times the 1, negative 1, we got negative 3, equals 12, if you can see that there. And so here we have 15 minus 3 equals 12, and equals 12. So here our 12 equals 12, and that proves that that variable x equals 5 is correct, for which we just did prove it just now.